Hello friends, in this video we will discuss a problem involving continuous time Fourier transform. It says that if x of t is a real function, then we have to prove that the double integral given here is a non-negative real number. Implies we have to prove that this whole integral is greater than or equal to 0. So that is the meaning of non-negative real number. So to solve this, we will take the help of the Fourier transform, which goes like this. So if you look at little bit carefully, the integral which is inside the square bracket, so given here, so this term can be written as, note that the integral is with respect to sigma, and finally the whole integral would be the function of omega. And if you look at little bit carefully, the term inside the square bracket is nothing but the convolution integral, and hence, so before we proceed, let us just for clarity purpose, let's assume this term is I. So and hence we can write I equal to integral minus infinity to infinity, and the term inside the square bracket we can easily see that it is nothing but our x of j omega convolved with x of j omega multiplied with e power j omega t naught into d omega. Okay, so let's assume that the term inside the square bracket is y of j omega, and hence our I would be equal to integral minus infinity to infinity y of j omega into e power j omega t naught d omega. Clearly this is looking like a synthesis equation, only term missing is 2 pi, and hence this would be equal to 2 pi times y of t with t replaced with t naught. Okay, so finally this integral turns out to be I would be equal to 2 pi times y of t, and y of t at t equal to t naught. So everything boils down to finding this y of t. Okay, so let's write like this. So y of t will have y of j omega as the Fourier transform, which is equal to x of j omega convolved with x of j omega. So clearly this is convolution in frequency domain, and hence what should happen in the time domain, the convolution should be replaced with multiplication in time domain, and hence in time domain, so this would be same as x of t multiplied with x of t. Okay, so x of t multiplied with x of t, so this fellow will have 1 by 2 pi multiplied with x of j omega convolved with x of j omega, and hence we can easily see that 2 pi times x of t or x square of t will have x of j omega convolved with x of j omega. So from this and from the result what we have just obtained, we can easily see that our y of t would be equal to 2 pi times x square of t. So and again this implies that I, which is equal to 2 pi times y of t, this should be equal, y is equal to 2 pi times y of t naught, which is nothing but 2 pi times 2 pi times x square of t naught, and this again simplifies to 4 pi square into x square of t naught. Okay, but it is given that x of t is real, and hence x square of t is always real number, x square of t is always positive number, and 4 pi square is also a positive number. So clearly we can say that this is always greater than or equal to 0. Okay, so Hope this problem helps you in understanding the concept of convolution in frequency domain property. Thank you.